Yeah, baby, we're live. We're live, baby. Yeah, baby. I want some light music that is not copyrighted. Can we get some? Let's see. I don't know if it's gonna fuck up my RAM, but I want some music, eh? I'm gonna open up an incognito tab so that I won't give away what I like and what I don't like, my preferences when it comes to things. Let me open up my live stream over here so I can see how many people are watching. Nobody is gonna watch this, but hey, let's see. Alright, we've got this working. And let me just open up YouTube over here and search for loyalty free lo-fi. I don't know if this is loyalty free. Oh, stop. I don't see any. All right.
That ad in the next.
Fuck this. All right. Okay. Nice. We're streaming, we're live. Let me lower the volume of the music a little bit. Alright, that sounds good. Alright, let's get to it. So, I saved a bunch of stuff from yesterday in this folder called Heaps. Let me see. Let's write a hello world program first of all, before anything. Let me just open up. Well, the funny thing is that so many of you guys ask me to do a tutorial on heaps and hacks and stuff like that, but nobody's watching right now. So I don't know if I'm gonna keep this up, because if nobody's watching, I'm not gonna spend time on it. Spend time, yeah. Let's see if you have a Haxe extension. Yeah. Haxe extension pack. It's Haxe and Flash debugger. I don't want a Flash debugger. What is this one? It's just language support. Yeah, that's what I want. Give me language support. Build is failing. Anyways. Hello world .hx. Let's make it main.hx, whatever. I don't want Docker. Update it. There's this, there's that. What's going on here? Right. Let's write the hello world. So it's class main, typical, then static, public, function. Alright, so you define functions with that keyword. Main and then return type as void, I'm guessing. And there's trace that prints something. Hello world, bitches. It needs to have a twist. You can't just. Right, I'm pressing F5. Haxe interpreter. Yeah, let's do Haxe interpreter. No Haxe configuration exists. Then what do you do? Create the Haxe lib. Then what? What is the next step after this? Learn Haxe introduction. Haxe language, has like features, standards, Haxe manual. What is Haxe about? This document, hello world. That's what I did. Right, let's see. So we've got Haxe, alright? So we'll do Haxe main interp. Alright, that works. Hello world, bitches. Alright. So we've got that. The hello world works. That means we've installed everything correctly. Then let's go to. Let's get a look at everything, basically. So we've got types. And something like the additional safety comes at the price because programmers are forced to explicitly assign types. This split type and notation are not required in Haxe. Can infer the type that's not good, but maybe that's good. It can be good. It can be good. This in C++, that's AS3, and that's in Haxe. So it's like where my button equal to new. Alright. There are 7 type groups: class instance, enum instance, structure, function, dynamic. What is dynamic? A wildcard type, which is compatible with any other type. Why? Then we've got abstract, the compile time type, which is represented by a different type at runtime. And then we've got monomorph, an unknown type, which may later become a different type. The fuck is that? Monomorph. Can click on it. Whatever. We've got the type system. A significant amount of type safety is achieved by checking if 2 given types are compatible, meaning the compiler tries to perform unification between them. Is detailed in unification. We briefly looked at type defs while talking about anonymous structures. What is that? I missed that part. Ooh, anonymous structures. We've got the basic types. This numeric, like int with a big I. Float. They can overflow. For performance reasons, the Haxe compiler does not enforce any overflow behavior. So PHP and JavaScript, they have no native int type. Loss of precision will occur if a number reaches the float limit 2 to the power of 52. We've got alternatively, Haxe and 32, Haxe and 64 classes can be used to ensure correct overflow behavior. Ah. But that'll like fuck up the performance, I'm guessing. Alright. These are good things to know about Haxe and how it works. They've got booleans. Values of type bool are common occurrence conditions, ifs and whiles, alright. They've got wait. There's a special case in the type system because it's not actually a type. It's used to express the absence of a type, which applies mostly to function arguments and return types. Wait to wait. We've got function types. We take a look at that as well. Nullability. It's common for programming languages to have single, clean definition for nullability. Haxe has defined a compromise in this regard due to the nature of Haxe target languages, while some of them allow and in fact default to oops, sorry. Hello! Oh, somebody's watching. How's it going, guys? Hey. Please type something in the chat. The chat is really empty. Alright. There's nothing to worry about when working with null on dynamic targets. Static targets employ their own type system where null is not a valid value for. There's too much volume in this music. All right. C++, Java, and C# targets or static targets employ their own type system where null is not a valid value for basic types, like in integers and stuff like that. There is no null. We've got default values, and then on static platforms, or you're gonna receive these. But you can use that, but that'll cost you some performance, I'm guessing, because that'll be a special class with an integer inside that can be null. But it's good to know that you can define nullable basic types. All right. That's what that's all this page is saying. Yeah, that's I had to search for the words for a moment there. All right, we've got optional arguments and nullability. Optional arguments are defined like. All right, why is null and nullable? All right, so if you define optional arguments, they're nullable. Oh no, this is also an optional argument, but this is an optional argument that is also nullable. If you put a array. I'm guessing I can define variables like that too. Like, can I do var x and then do end with the question mark? Nah, that only works in functions, I'm guessing. When you're working with arguments. Alright. Alright. Then we've got class instance. It's pretty basic. Class constructor. Alright. This something I need to like remind myself of. Constructor. So class constructor, but calling class constructor process instantiation. But how do you write? Oh, alright. That's the constructor. Public function new. It has a new function. That is so weird. And then we've got this pointer. Alright. And ooh. Let me take a look at the inheritance. Uses the keyword extends. Just a couple of things to remind myself. That's all. We can use super duper. Then we've got interfaces. Implements. Alright, so you can use that. And you define like interface. You define the signature of it. Alright. And then we've got abstract classes that have partial implementation. And we define them using the abstract keyword, and then we use extends because they're classes. Alright. Accelerate. Alright. So far so good. What else? Accelerate. So you can define the variables, have a bunch of stuff, but then your functions can be abstract too. That's the thing. Okay. Do you like overwrite that function? Get reals. It's no keyword overwrite. That'll put some weight on the compiler. Alright, we've got enum, pretty basic. We've got enum constructor. Ooh. That's pretty weird. This line is weird. So you can do enum of type color. That's basically a class. But is that the constructor? Some of the classes and their constructors enums can be instantiated using their constructors. They're all of type color. Like, how does it detect that this is of type color? Red can be in multiple enums. It's weird. All enum instances can be assigned to a special type named enum value. It's important to distinguish between enum types and enum constructors. This example demonstrates. Alright, so the constructor should accept values for each of these guys. But how is that an enum? Let me see. We need to test this, guys. I don't understand this. Enum. Let me define it like in the class. Enum. Color. We're gonna have red, green, and blue. We're gonna have RGB. Is that a constructor? Int G int B int. Alright. So what happens if we call the constructor? Like var c is equal to RGB 2552550, and then can we trace C? Expected. What? Oh, you can't define an enum in a class? Are you kidding me? Is that what it is? That is so weird. How's that an enum? It's like RGB 255. So how can I use C? Match equal. Get name. Allez. Tu know
동물가서 완전히 오케이. 동물가서
That wasn't a problem.
Hoş geldiniz. Önemli ki. چند نفر تصویر تو؟
You know.
سلام برسون.
My friend says hi. Right, the name of the enum is. Sorry about that. Name of the enum is RGB. What is that? Wasn't it color? This doesn't make any sense to me. How's it a constructor? Makes no sense. How is it? That's not an enum. I don't understand it. Anyways, I'm gonna let this part of the problem rest in my mind for a bit. Using enums. Enums are a good choice if only a finite set of values should be allowed. Oh, so that's how. Oh, alright. So an enum can hold values. That's what it is. Oh, I lost every viewer there. It's because my friend came in and asked me about something. That is brutal. So if the game is that brutal, I must be brutal too. I shouldn't be streaming if nobody's watching, right? If you guys are gonna be that brutal, that hurt me a little. Ooh. I don't know, man. Whatever. So we've got that. Using enums. Alright. Got anonymous structure. Can be used to group data without explicitly creating a type. Ah, so it's like JSON. Anonymous structure. What the fuck is that? Just call it Jason, motherfucker. Anonymous structure. Cause we are different. This is not a Jason. This is an anonymous structure. That is Jason. Fucking people. That's nice. Alright. Then we've got Jason for a structure. Class notation for structure types. Type def point equals to that. Class notation for structure types. Type def. Alright, so you can define a type using those. That's pretty neat. Then we've got optional fields. That's an optional field. So you don't need to fill it every time you create user. User might not contain a phone number. At sign optional metadata can be used instead. Alright. Impact on performance using structures and by extension structure subtyping has no impact on performance when compiling to dynamic targets. However, on static targets, access is typically slower. Alright, so you shouldn't be using these unless you have to. That's an easy solution that comes at a cost. Then we've got extensions. Extensions are used to express that the structure has all the fields of a given type. What is that? That looks so weird. Created an operator. Oh, that's defining an operator. Denotes an extension of. It's being created. Oh no, that's not defining operators. That means we're creating an extension of an iterable type of type T. Type must be compatible with iterable T and provide a read-only length property of type int. But why does it have a comma at the end? Why not a semicolon? So because it's extending something? It's so confusing. Oh, so you can use a notation like you can use the ampersand. Great. Interesting. So can extend other types, other anonymous structures. Alright, let's take a look at the function type. We're gonna just take a quick look at everything. And we're gonna just be aware of the things that exist. You don't need to know all the details, you just need to be aware of them. So that if you need to use something, we'll know if it exists or not. Hope that makes sense. Alright, function type. you can do $sign type test. That is type of this function. Ah, alright. But then to define the type, you can use this expression here with the dash greater than sign. Just like int, sorry. Oh no, it's like I int s string and then bool. It returns a boolean. Alright, good to know that. But yeah, you can't just not name it. That's a valid option too. For example, int that. Alright. That receives a function. That's a type for a function that receives a function in its input. Alright. That's good. We've got optional arguments. How do you define them? Just using that question mark. And you can actually define them as null if they're nullable. So this question mark in type definition is a bit different than the question mark in function definition. Like in here, that means they're both nullable and optional. But in here, that just means they're optional. If you want nullability, you can use that. But it says something else here. I'm a bit confused about this, but that's not that important. Those details. We shouldn't go too deep into the details. We've got default values. We've got type. Main and test and stuff like that. What's default values for function types? What is that? Haxe allows default values for arguments by assigning a constant value to them. Is that what you mean? Ah. Alright, then we've got the dynamic type. It can be anything. It's really stupid in my opinion. I'm not that type of guy. I don't use dynamic values. I don't do that shit. You can do everything without using dynamic values, so I'm just gonna let that go. We've got abstract types. Inline public function new. There's actually a different type at runtime. What is inline public function? What is an inline function? Need to learn about that. I've got implicit casts. What's that? From int to int. My abstract as being from int and to int appropriately, meaning it can be assigned from int and assigned to int. What? This should line 9 and 10. There is no lines here. There's no line numberings. What are you talking about, bruh? Take care of your documentation, bruh. Where we first assign the int 12 to a variable a of type myAbstract. This works due to the from int declaration. Oh, you can assign ints to it. You just set it equal to 12. Because you set from int, this'll work. And then you can cast it to integers. So if you say to int, then this'll work too. But how does it work? Oh, it's of type int. You can actually define how that works. You can do @, colon, from, and then say static public function from string. Then that works, from string. You can do to array, then that works. It's such a weird thing to have. You can just have a function for it, man. It's going to define implicit casts for your abstract classes. Alright. I'm guessing you can do that for your non-abstract classes as well. Alright. We've got operator overloading, operator overloading. You can overload that operator. Ooh, interesting. That's some interesting functionality. Operator overloading. Alright, we now know the name of that operator overloading thing. Feeling a bit sleepy. But anyways, we need to finish this part. I've been streaming for 38 minutes. What if I turn this off? It's getting ready to go to bed. I'm looking at the wide screen, so that doesn't matter. I'm still gonna be looking good. Array access. Array access describes a particular syntax traditionally used to access a value in an array at a certain offset. It's key of type K. What is K? Get array right key and value. Does that set key and value? Alright, so you can define custom array types, array access types. Interesting. And then we've got enum abstracts using @, enum. That abstract can be used to define finite value sets. That is also a really weird thing to have, but I don't know. I guess it's useful. Then we've got forwarding abstract fields. When wrapping an underlying type, it's sometimes desirable to keep parts of its functionality. What's happening here? Forward push poop. They're similar, man. Push pop. This example wraps array. It's that metadata for metadata has two arguments which corresponds to the field names to be forwarded to the underlying type. So extends this, and push and pop are forwarded to this type, so that our type doesn't have to handle push and pop. But then you need to set this pointer to an array, which can be problematic. Some of these stuff are a bit stupid to me, at least. Core type abstract. What is monomorph? A monomorph type which may, through unification, morph into a different type later. And we've got type system, type def, type parameters, generic, variance, unification, type inference, modules and paths, and then untyped. We've got class fields, property method access modifier. We've got expressions. Blocks of code and return F new and stuff like that. We've got language features, conditional compilation. Interesting. Then we've got externs. I had to go over every one of these guys, but I don't feel like it right now. I'm gonna hit the bat and then see you guys tomorrow. We're gonna read all of these things. Yeah, Then we're gonna take a look at the Haxe. I'm sorry. We're gonna take a look at the Heaps.io source code to see how it's working. But before that, before taking a look at it, at the source code, I'm gonna try and use Haxe with different libraries. For example, graphical libraries, something like SFML, and see if it can handle that. Then if it can use libraries and compile to C++ and use libraries, then we can do stuff like create a simple game engine or something, or like try to guess how it would be done, and then take a look at the Heaps.io code, understand how it actually works, and then combine Heaps.io with physics engine libraries and all these different kinds of libraries to make it more powerful. And then we're gonna make a game. Yeah, baby. So yeah, that's it for today. Thank you guys for keeping quiet and not chatting, because I really like it when nobody's chatting, nobody's outputting in a message, and nobody's supporting my videos. Nobody likes me, and I really like it when I die alone. But yeah, see you guys in the next one if you show up or whatever.